Differentiation is a fundamental concept in calculus that deals with the rate at which a function changes. The derivative of a function at a point provides the slope of the tangent line of the function at that point. If a function is a function, its function. This is useful in various scenarios, such as minimizing the cost of materials for a given project or maximizing the area enclosed by a fence. The application of differentiation in finding applied maximum and minimum values is a crucial concept in calculus. Maximum and minimum values, often referred to as extremum, are the highest and lowest points on a function within a given domain. These points are critical because they help us understand the behavior of functions and solve optimization problems. To find this extremum, we use techniques such as setting the derivative of a function to zero to find critical points. The critical points are where the slope of the tangent to the function is zero, meaning the function has a horizontal tangent line at these points. However, not all critical points are necessarily maximum or minimum. They could also be inflection points. To determine whether these points are maximum, minimum, or inflection points, we use the second derivative test. By evaluating the second derivative at the critical points, we can determine the concavity of the function at those points. If the second derivative is positive, the function is concave up, indicating a local minimum. If the second derivative is negative, the function is concave down, indicating a local maximum. If the second derivative is zero, the test is inconclusive and we may need to use other methods to determine the nature of the critical point at which a function changes. The derivative of a function at a point provides the slope of the tangent line of the
Now we move
critical
to the
point.
process. First,
Mathematically,
we must
if
find the
x
derivative.
is
Second,
a function,
let the
its
derivative
derivative
equal to
denoted
0 and
as f
find the
times x
values of the
measures
variable.
how f x
Third,
changes with
we
respect
make
to
a
x.
second derivative to
Differentiation
test
is
which,
essential
which is
for
its
understanding and
minimum value
analyzing
or
the
maximum value.
behavior
If
of
it's
functions,
more
especially
greater than
in
0,
determining
so
the rate of
it
change.
was the
Finding
minimum
a
value.
local maximum and
If
minimum, and
the number
solving
is
problems
less than 0,
involving
it
motion and
shows
growth.
that it was the maximum
One important
values.
application
Right,
of
now it's my
differentiation
turn. Let's
is in
begin.
solving
First of all,
equilibrates
let's
problem.
read the question for this
These
problem
problems
statement first.
involve
A
finding the rate at
manufacturer
which
wants to
one
design
particle
an open
changes
box that
with
has a
respect
square base
to
and a
another
surface
quantity
area of
that is also changing.
144 cm
For
square.
example,
Find
if
the
you have a
dimensions of
balloon
the box
made in
such
clay,
that the
you might
volume is
want to know
maximum.
how fast
Next,
the
determine the
radius of the
maximum
balloon
volume.
is increasing.
Next, let's
You
find
might
the
know
solution
the
for
rate
this
at
question.
which the
The goal
volume
is to
is
find the
increasing.
dimension of a box that gives
Differentiation
the
allows
maximum
you
volume.
to
The
relate
volume is
these rates
expressed as
using the
V
chain
equal
rule.
to x squared
In an
y, where x
application
represents the
is an
side length of the square
optimization
base
where you use
and y is
derivative
the height
to
of the
find the
box.
maximum or minimum
Additionally, the
values
surface
of a
area of the
function.
box is given as
This
x
is
squared plus
useful in
4xy equal to
various scenarios
144,
such as
where
minimizing
x squared is the
operating
area of the
costs
base
of
and
materials
4xy
for a
is the
given
total
project,
area
or
of the four
maximizing
vertical
the
sides.
area enclosed
Express
by a
y
fence.
in terms of x.
The
From the surface
application of
area equation,
differentiation in
isolate
finding a value
4xy to get
maximum and
4xy
minimum
equal to
values is a
144
crucial concept
minus
in
x
calculus.
squared. Dividing
Maximum
both
and
sides
minimum values,
by 4x,
often referred to
then
as
we
maximum,
find y
are
as
the
a
highest and
function of
lowest
x,
points
which
on
is
a
y equal
function
to
within the
144
given domain.
negative
These points are
x
critical
squared
because
over 4x.
they help us
This allows us
understand
to
the
express the
behavior of
volume in
functions
terms of x
and solve
alone. Substitute
optimization
y into
problems.
the volume formula.
To
Substitute
find
y
this
equal to
extreme, we use
144
techniques such
minus
as
x squared
setting
over
the
4x
derivative
into
of a
v equal to
function
x
to
squared y.
0 to find
So it
critical
will be
points.
v equal to x squared
The
times
critical points are where
144
the slope
minus
of the
x squared
tangent
over
to the
4x,
function
and
is
simplify
0,
this
meaning the
expression, and it
function
will be
has a horizontal tangent line
36x
at these
minus
points.
1 over 4x cubed.
However,
Now the
not
volume is
all
expressed
critical points are
entirely in terms of
necessarily
x.
maximum
Let's
or
move to the
minimum.
step 1. Okay,
They
for the
can
step
also
1, we
be
have to find
inflection
the
points.
first derivative. To
To
maximize the
determine
volume,
whether these
differentiate
points
v
are
equal to
maximum,
36x
minimum, or inflection
minus
points,
1 over
we use the
4x
second
cubed with
derivative test.
respect to x.
By
It will be
evaluating
dv
the
over
second
dx equal
derivative
to
at the critical
36
points,
minus 3
we
over
can determine the
4x
concavity of
squared.
the function
For
at
step
those
2,
points.
okay, we have to
If the
set the
second
first
derivative is
derivative to
positive,
0. To
the
find the
function is concave
critical
up,
point, set dv over dx
indicating
equal
a
to
local minimum.
0. So it will
If the
be
second
36
derivative
minus
is
3
negative,
over
the
4x
function
squared
is concave
equal
down,
to 0.
indicating a
Rearrange to solve
local
for
maximum.
x squared.
If the
36
second
equal to 3
derivative
over
is
4x
0,
squared.
the test
Then
is
48 equal
inconclusive,
to x
and we
squared.
may need to
So
use
x equal
alternative
to square root
methods
of
to determine the
48
nature
centimeter.
of the
Furthermore, for step 3,
concavity
we have to find the
at
second
which a
derivative test
function
to
changes.
confirm whether this
The
critical
derivative
point gives
of
a
a function
maximum.
at a
Calculate the
point
second derivative,
provides the
which
slope
is
of the
d square
tangent
v
line
over
to the
dx square
function
equal
at that
to
point.
negative 3 over
The
2x.
case
Then
when
substitute
x
x equal
is
to
a
square root
function,
48
its
into
derivative,
it and
denoted
get
as
negative
f prime x,
10.39. Since
measures
the
how
second
f x
derivative is
changes with
negative,
respect
x
to
equal
x.
to square root 48
Differentiation
corresponds
is
to a
essential
maximum.
for
Find
understanding
y
and
when x equal
analyzing
to
the
square root
behavior of
48.
functions,
It is
especially in determining
3.46
the rate of
centimeter.
change.
Last but not
Finding
least, we
a
have to
local
calculate the
maximum or
maximum
minimum
volume.
and solving
So we
problems
just substitute
involving
x
motion
and
and growth.
y into volume formula
One
and we'll
important
get
application
the
of differentiation is in solving
166.08
related roots
centimeter cube,
problem.
or
These
alternatively,
problems
use the
involve
simplified
finding the root of
volume
each one
formula that's already
quantity
derivative
with respect
and
to
get the
another
value
quantity that is also changing.
166.28
For
centimeter cube.
example, if we
So
have
that's
a hot
all.
balloon,
Let's move to the
then
next
we might
part.
want to know how fast the
Lastly,
radius of the
to
balloon is increasing,
application of
and you know the rate at
differentiation
which the volume
to
is
determine
increasing.
the maximum and minimum
Differentiation
value
allows
is a
you to
flexible and
relate these
important
rates
tool
using
that
the chain
can
rule.
be used in this
Another
topic.
application
Hence,
is in optimization,
identifying
where you
and
use
using
derivatives
formula for
to
both
find the
the
maximum
first
or minimum
and
values
second
of a
derivative is
function.
important to
This is
determine
useful
whether
in
the
various scenarios,
condition
such as
reach a maximum or
the
minimum
cost of
values.
materials
Lastly,
for a given
these
project, or maximizing
mathematication
the area
methods are
enclosed
important to
by a
improve
fence.
understanding and
The
optimize
application
the
of appreciation
efficiency
in finding
and
a post's
efficiency
maximum and minimum
for
values
the
is
solution.
a crucial concept in calculus. Maximum and minimum values